Welcome back. Thank you for joining me for our Chapter 9 review for Expo. So, Chapter 9, we talked all about quadratics, so degree 2 things. And I broke this down into 5 different learning targets. We started with graphing them and doing some vertex word problems. Then we moved into a bunch of solving methods, solving by square rooting, solving by factoring, solving by the quadratic formula, and then wrapping up the chapter with identifying linear, quadratic versus exponential functions. Can you tell the difference between how they look? So let's dive in since we have 5 learning targets to cover in this video. So remember the basics of graphing a parabola in this form. So if that first term is positive, remember the parabola is going to open up like a smiley face. If it's negative, it's going to open down. If a is greater than 1, it'll be narrower. If it's less than 1, it'll be wider. Okay? So here, when I say graph, maybe a better word would be sketch. Okay, I'm just going to sketch these for you just so you can see what's going on. Now, the basic one, that most basic one, we're talking about these values right here. Oh, I'm sorry. 0, 1, 2, and just squaring them. So 0 squared is still 0, 1 squared, 2 squared, negative 1 squared, negative 2 squared. So this is our most basic parabola, okay, looking like this. Now, the reason I'm saying sketch is because I'm not going to make you specifically graph these, but what I want you to be able to do is recognize what's going to be happening. So when I look at this one, remember that 2 is positive, so it is still going to be opening up. However, that 2 is going to stretch on it like silly putty. Okay, so remember, that's going to make it narrower than before. So this 2x squared, again, I'm not going to make you actually graph it, but it's going to go up faster than just x squared would. Okay, so again, just a little tidbit for you for recognizing these, because on the final, you're going to have to recognize these graphs. It's not going to make you actually plot every individual point, but I want you to see what's going on. Same thing right here. So this time that negative means that this one is going to be opening downward. And remember the fact that this is fractional, that 1/2. That means it's only going up half as quickly. So it's going to appear to be wider, right? Think of taking a silly putty, flattening it down to half its size. It's going to kind of pudge out a little bit. So not only is it going to be opening down, but it's going to be wider than the other two because of that. Okay, so again, you don't need specific points here. It's the general idea that I want you to remember. Positive means up, negative means down, and then a whole number, a big number, means it's going to go up faster. It's going to be narrower. A fraction or something less than 1 means that it's going to be a little bit wider. So again, that was the very basics we started graphing with. Then from there, we dove into the full graphing. So if I give you something in this form, a full quadratic, do you know how to graph it? Okay. So remember, the first thing was finding that axis of symmetry. Okay. So this is one of the formulas that you will want to make sure you have memorized for your final. Negative b over 2a. You're going to absolutely need that for your final, okay? So maybe highlight that for me because it is something that you want to make sure that you know. So let's start there. Well, negative b, so here my b is 6. So I'm going to have negative 6 over 2 times a. Well, a is 1, so 2 times a is 2. So my axis of symmetry is going to be the line x equals negative 3, right there. All right, well, so that's a good start. So now let's talk about how do we find the vertex? So remember, that was the next component. The vertex meaning the highest or the lowest point, right? And it always lives on that axis of symmetry. So what that means is if I take that -3 and I plug it into the original function, that'll tell me where my vertex is. Because right now I know its x coordinate. I can use the original function to get the y coordinate. All right, so I plug it in to the original x squared plus 6x minus 1 to get 9 minus 18 minus 1. And I believe that should give you -10. So here is my vertex sitting right here. And then remember, the other important thing was the y-intercept, the 0. Okay, so remember the y-intercept always took this form. It was always putting 0 in for x, and consequently, a 0 for x always means we're only looking at this value right here, because x's will become 0. So we get this point just sitting down at -1. Okay, the y-intercept. But now we have a point that's off of the axis of symmetry. So remember, that also always got reflected to the other side, right? Whenever you plotted a point that was not on the axis of symmetry, it simply got reflected to the other side. And that gave us our graph. All right, so again, remember those couple steps. And the nice thing is on the final, when this is multiple choice, you just have to be able to recognize the right one. So you'll want to sketch out, find all those things, and then just look to recognize, well, which of the multiple choice options matches what you just graphed on your paper. So let's keep moving. So again, another component to this, we talked about graphing, and then we also talked about vertex word problems. So when asked to find a maximum height or a minimum height or anything like that in a word problem, you want to start by finding that vertex, right? So here, that -b over 2a is still going to be important. Okay, so if I want to figure out how long it took the ball to reach its maximum height, I need -b over 2a. Again, this being a, b, and c. All right, so again, the component here, the key thing is you're asking for maximum height. That tells me I need my vertex. Vertex being -b over 2 times a. And of course, this is where a calculator will come in handy. So -20 divided by -32 is going to be 0.625 seconds. So the ball will reach its maximum height after 0.625 seconds. Then to find what that maximum height actually is, we take that 0.625 and we plug it back into that original function. And of course, this is definitely going to be done on your calculator. So what I recommend right now is pulling out your calculator and then checking to make sure that you get the same answer that I am about to get. So I get an answer of 9.25 feet. So double check that you can get that too, because if you can't, hey, great opportunity to come and ask me how you're typing in wrong to make sure you can do it right before your final. Okay, so double check right now that you're able to get those answers as well. So that covers our first big learning target of this chapter. And then remember I talked about, then we dived into all of those solving methods, all the different ways we can solve quadratics. And we focused mainly on 3 ways. First, we focused on solving by square rooting. And solving by square rooting, what that means is get the x squared by itself. So for this first one, that means adding the 36 over. Once it's by itself, now we're talking about square rooting both sides. Well, the square root of 36 is 6, but then we always have to remember we're looking for two answers. Quadratics have two answers. And when I'm square rooting, those two answers come from plussing and minusing. So remember, whenever you square root, plus or minus, okay? Don't forget it. The next one, getting x by itself, this time takes two steps. I'm going to add the 50 over and then divide by 2. And now that the x squared is by itself, square root. And in the process of square rooting, please always remember the plus and the minus. So again, that was probably the easiest of our solving methods, quickly followed by our next one, solving by factoring, okay? So solving by factoring, the reason we use it is because that dives into what we call the zero product property, right? It comes from the idea that if two things multiply to be 0, at least one of those pieces must be 0. So what that means is this, that 3x minus 2 has to be 0, or the x plus 5 has to be 0. Now the x plus 5 being 0 is one of the easiest things ever, right? That just becomes negative 5. The other one takes a little bit more work. And what I mean by that is you have to add the 2 over, and then you have to divide by 3. But that's how we get our two answers, okay? Both pieces could equal 0, so you have to solve them both for 0. Now you may be wondering where factoring comes into this. Well, remember the reason factoring comes into play here is because sometimes you have to factor it to get it to look like that for the zero product property to work. So again, if it ever says solve by factoring, well, good idea, probably factor first. X times x gives us the x squared. To get to negative 15, well, to multiply to be negative, we need oppositely signed things. And so I'm thinking a positive 5 and a negative 3, because those will multiply to the negative 15. Those will add to the 2. And then, of course, this x plus 5, for that to be 0, x would have to be negative 5. For this x minus 3 to be 0, x would have to be a positive 3. And again, you end up with your two solutions. The next one I put on there has a little trick to it because remember, you can't factor across an equal sign, all right? That doesn't work. So for this one, the first thing that you have to do is make sure it's set equal to 0. Remember, whether you're factoring or using the quadratic formula, anything like that, you need to make sure that it's set equal to 0 first, all right? Once it's set equal to 0, well, now you're in good shape to factor. X and x give us the x squared. To multiply to negative 20, again, we need two oppositely signed things. A combination that multiplies to negative 20 adds to positive 1. We're going to be talking about a positive 5 and a negative 4. And then, of course, this x plus 5, for that to be 0, x would have to be negative 5. For this to be 0, we're talking about x equaling positive 4. So again, that was solving by factoring in a nutshell, right? Get everything to one side, factor it, get both of those pieces equal to 0. Well, then we had the quadratic formula, okay? So the quadratic formula, this is another thing I would definitely highlight in your packets. You're going to have that memorized, okay? And I know it's been a while since you've had to use it, so probably a very good idea. Highlight that, look at it, you're going to need to know it, Okay, so for both of these, here A is 2, B is 3, C is 2. So let's go and plug all this in. Negative B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. And remember, the first place I like simplifying is inside the square root, right? The first thing I always did is I got a number for that. Well, 3 squared is 9. 4 times 2 times 2 is a negative 16. All right, so 9 minus 16 will get us a negative 7. Now, that's going to cause a dilemma, okay? Because hopefully you remember, you can't actually square root a negative, right? That's not actually a thing. So here what ends up happening because of that is this doesn't have any real solutions. Okay, if you end up with a negative inside your square root, it's not going to happen, right? Then you just put, hey, no real solution, move on to the next one. All right, so let's try it again. So here, A is 1, B is negative 3, C is negative 5. So this time negative B, well, since it's already negative, that becomes a positive 3 plus or minus B squared minus 4 times A times C all over 2 times A. Just like before, the first thing that I want you to do is deal with that for me. All right, now a couple important details to remember about the quadratic formula. Is this quantity negative 3 squared? Remember, if you're squaring a negative, it's still positive, right? And here, this double negative here, negative 4 times negative 5, makes that positive. So be very diligent, be very careful with your signs when you're doing these things, when you're plugging these in. So when I simplify this, what I end up with looks like this, okay? And remember, this really means two things to plug into your calculators, right? So this really has a positive answer, 3 plus square root of 29 over 2. So I'm going to plug that in my calculator. So remember, 3 plus square root of 29, hit enter to actually get a number, then divide by 2 to get 4.19. And it means the opposite as well, that minus. So 3 minus square root of 29. Hit enter, then divide by 2. That'll give me negative 1.19 to get my two solutions. Again, what I highly recommend, I've already said this earlier in the video, is try that out. Make sure you get those same numbers as me, all right? Because if you don't, I want you to come up to me and show me what you typed into your calculator so I can help you make sure you can get to the right thing. So again, please take the moment, plug those into your calculator, and make sure you get those numbers. Our final learning target. So our final learning target is identifying linear, quadratic versus exponential. Okay, so when we're doing this, remember linear just means a straight line. So hey, cool. This is linear. Quadratic is what forms a parabola. So this would be quadratic. And then exponential is the curve like this. Whoop. All right, so You want to make sure that you recognize all of those, okay? If you're looking at a graph, be able to identify those three things. Now, sometimes you'll be given a table of data, and it may ask you to identify which kind of model it comes from. So what I do then is make a quick sketch. So for example, here, I could give you this and ask you, well, which type of graph would that make? Okay, and what you'd have to do is just do a rough sketch of those points. So you can see that here, right? Rough sketch. And you can see, oh, it's making a parabola. Therefore, I know that this is a quadratic. All right, so again, the points don't have to be perfect. Literally just do a rough sketch of the points, okay? So what I mean by that is right here, here we have day 1, we have 0. Day 3, 1, 2, 3, we have 4. Day 5, 1, 2, 3, 4, 5, we have 8. Okay. Day 7, we have 12, which would end up here. But notice when I sketch those, again, just rough sketch. You don't even have to do all of them. Just give me a rough sketch, and you can pretty quickly see that those points are in fact linear. This next one, well here this gets a little bit difficult to sketch because notice how big those numbers get. But even if we were to do the first couple, so 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So 2 and 12 puts me right there. 4 and 48 puts me right there. Now I go to 6, and that's way up here at 192. So right away, even again, just looking at a couple, notice that's not going to give you a straight line, okay? So again, it doesn't have to be a perfect graph. Just sketch me what's going on. But you can see right away that those are definitely not forming a straight line. And notice it is consistently going up though, making this exponential. So that wraps up these notes, okay, this review. Once again, thank you so much for joining me. What you're going to do for me now is you're going to go log into Schoology, take those 5 quizzes for me, okay, based on the 5 learning targets we just talked about. So again, thank you for joining me. Go have fun taking those 5 quizzes.